In this video, we are going to take a look at how to use the natural logarithm and then how to solve natural logarithmic equations. So let's first take a look at the natural logarithm. The natural logarithm, which is denoted ln, that is equivalent to saying log base e. And remember, e is our natural number, which is approximately 2.718 and so on. It is an irrational number, so that decimal place never ends and never repeats. So ln is just a shortcut to using log base e. And because e is so prevalent in many math fields, they wanted to create a shortcut so they didn't have to write this completely out. And ln represents the natural logarithm. So let's look at how we use it. The same rules of logarithms apply since it is a log. Just because we're calling it ln doesn't mean it's not a log. It's a log, it's log base e, so all of the same properties apply. So let's go ahead and take this first example here, and we're going to go ahead and simplify it down into one log. And the very first thing we always do with numbers in front, we always replace them as the exponent. So ln of 15 squared, that 2 goes back into its exponent location, minus ln of 75, and we know 15 squared is 225. And then we are going to take a look, and we have two logs that are being subtracted. They both have the same base because they're both log base e being subtracted, so we're going to combine them into a single log using division. And so this is going to equal ln of 225 divided by 75. Okay, I'm going to put that in parentheses, and we can simplify this fraction. 25 goes into both of them. 25 goes into 225 9 times, and then 75 3 times, and I notice that I can continue to simplify. That is, the natural log of 3 is the answer. And let's go ahead and now move forward, and let's take a look at how to solve an equation with a natural log in it. Well, first off, just like in any logarithmic equation, we're going to go ahead and convert our logarithm into exponential form, but only when we are down to one logarithm. Here we have one logarithm, so we can go ahead and convert it to exponential. But before we do, I'm going to convert it, my ln, to log base e, just so that all you guys can see how I'm doing my conversion. Alright, so since ln and log base e are equivalent, now I can go e to the fourth equals this. So it's going to be e to the fourth equals x minus 3 squared. And how do I get rid of a square? I take the square root of both sides. And remember, when you take the square root of both sides, you need a plus or a minus in front. So it's going to be plus or minus the square root of e to the fourth equals x minus 3. And now let's go ahead and simplify this. A square root, we're looking for groups of 2. Here we have 4 e's, so we're going to pull 2 of them out, plus or minus e squared, and that equals x minus 3. And then we're going to go ahead and add 3 to both sides, so we're going to get 3 plus or minus e squared equals x. And since this is squared right here, I know that anything that I plug in for x, once I square it, is going to be positive, so both of these answers will work. So in this case, in this logarithm, I have 2 answers. So let's go ahead and do the same thing here. This one's a little bit easier. We're going to go ahead and rewrite our natural log as log base e until we get used to it. Okay, so now let's go ahead and change it to exponential. It's going to be e squared equals x. E squared equals x. And since this is pretty much as simple as it gets, x is already solved for, and e squared is a positive number, and when I plug it back in, that is our answer. X equals e squared. Alright, so let's go ahead and solve this. Again, we only have one logarithm, so we're going to go ahead and convert this logarithm to natural log to log base e, just so we can see it. And we don't actually have to do that if you don't want to. As soon as you get used to seeing the natural log written here, you don't need to write log base e. You can go straight to the conversion. Okay, so we are going to go ahead and change this to exponential form. So we get e to the fourth, e raised to the fourth power equals this, 3x plus 5 squared. Again, how do we get rid of a square? We're going to take the square root of both sides, and when we take the square root, we have to put a plus or minus out in front. So we get the square root of e to the fourth equals 3x plus 5. All right, the square root of e to the fourth, we did that earlier. That is going to be plus or minus e squared equals 3x plus 5. We're going to move our 5 over, so we're going to get negative 5 plus or minus e squared equals 3x, and then we're going to divide both sides by 3, and when we're done, we have this. Again, no matter what we put in for x, when we square it, it will become positive. So we can have negative and positive answers. Okay, so now let's take a look at this last example. In our last example, we have 2 logs, and we can't convert to exponential unless we have 1. So let's go ahead and convert by using, since we have an addition here, we're going to combine into 1 log by using the product property. So we have the natural log of 2x times 3, which is 6x, equals 2. Now we're going to go ahead and convert. I'm not going to write ln as log base e. I'm just going to go ahead and do the straight conversion. Knowing that there's an e down here, I'm going to say e squared equals 6x. So we have e squared equals 6x. So how do we solve for x? We divide both sides by 6, and we get e squared divided by 6. And if we plug this in, e squared is going to be positive, so a positive divided by a positive is going to be positive. When we plug it in here, that makes this positive. E squared over 6 is our answer. And that's how we use our natural logarithm.